12.2, multiplying and dividing rationals. The basic principle of fractions. So when you have a times c in the numerator and b times c in the denominator, that is also equal to a over b. And the reason why is the c in the numerator and the denominator end up canceling each other out. And the reason why the c's cancel each other out is because c over c is equal to 1, leaving us with just the a over b. Factors and prime factors. Numbers or expressions that are multiplied to get other numbers or expressions. So 4 times 3 is 12. 4 and 3 are the factors of 12, just like 1 and 12 or 2 and 6. However, 2 times 2 times 3 are the prime factors of 12, and the prime factors of 12 are unique. You can do the same thing with expressions. 2 times the quantity x squared minus x minus 6 is a factor of the trinomial 2x squared minus 2 minus 12. But down below, this is the prime factorization. 2 times the quantity x plus 2 times x minus 3. And the prime factorization is going to be more useful to us as we're simplifying the numerator and denominator. I'm going to have you do most of this next section yourself. I'll do the first one as an example. I want you to simplify each fraction using prime factors. So you need to determine the prime factors of the numerator and the denominator. So for this first question, we have 3 over 6. The numerator is 3, which is prime, and the denominator is 6. So we'll break that into its prime factorization. We'll see that there's a 3 in the numerator and the denominator, allowing us to cancel it out, making it a 1. Now all we have is a 2 in the denominator. There's nothing in the numerator, so what we put up there as a placeholder is a 1. So this is the work that I want you to show when you're doing these next few questions. Break the numerator and the denominator into its individual prime pieces, and then cancel out anything that is the same in the numerator and the denominator. All right, in this next section, we're going to work with equations. We're going to do the same process of simplifying the fractions, and then we're going to communicate the lost domain. And so that is going to be called a restricted domain. And the reason why we lose a x value in the domain is because you cannot have 0 in your denominator, and there will be an x value that creates a 0 in the denominator. So for this first one, start by writing the equation, and you do not have to go to the prime factors in this process unless you need to. So I'm not going to break 6 into 2 and 3. I'm going to leave 6 alone for now. And in the denominator, I'm going to factor a 6 out, and we will see that the 6 in the numerator and the denominators cancel, and we will have f of x equals 1 over 2x plus 1. And so now we have to answer the domain. What x value cannot go into the denominator? So you can start with the domain from the beginning, and you can also look at the domain at the end. Let's start up here. So 12x plus 6 could not equal 0. So when does it equal 0? It would equal 0 at negative 1/2. And so the domain would be from negative infinity to 1/2, and from negative 1/2 to infinity. Let's try this next one. Start by writing the equation, and then we will factor the numerator and the denominator. There's a 2 that you can take out of the numerator, and there's a 5 that you can take out of the denominator. And instead of being able to cross off a constant top and bottom, we'll be able to take off x plus 5. from the top and the bottom. So g of x equals 2/5. Now, when you look at the final answer, it appears as though our x has disappeared. And so when you're looking for your domain restrictions, it doesn't help you to look at your final answer. You'll have to look at where you started and think about what x's could not go into the equation. And so we will set the denominator equal to 0, and we'll figure out what values do not work. So x could not equal -5. I'm going to answer this one also in interval notation, -infinity to -5, union with -5 to infinity. Right. And this last one will be the last one that I do. Number 4 will be left for you to try. H of x equals 2x squared minus 7x minus 4 over x squared minus 3x minus 4. The denominator looks a little bit easier, so I'm going to start with that one. With the denominator, I'm going to make a box. I've got -4 and x squared. I need to figure out two numbers that multiply to make -4, but add to make -3. That's 1 and 4. And it was a -3, so that'll be -4 and +1. The denominator is x minus 4 times x plus 1. The numerator is a little bit more tricky, so I'm going to try the AC method, where we take the first term and we multiply it by the last term, so that's -8x squared, and then we'll put our middle term below. Got to figure out two numbers that multiply to make -8x squared, but add to make -7x. So that is 8x and 1x, and we'll have that be the -8. So that AC method helps us fill out the inside of the box. I know that I have 2x squared and a -4, and I will have a -8x and a 1x, and now I can go about filling out the outside of the box. 2x and x, and this will have to be a 4, and this will have to be a 1. I do need a negative somewhere, and it looks like that's where my negative is. Okay, so now I'll bring my side links over and write down my factors. I will have x minus 4 and 2x plus 1. I can cancel x minus 4 out. I'll simplify this to be 2x plus 1 over x plus 1. Now we need to work on the domain. So in this one, the domain couldn't be two numbers. It could not be -1 or +4. And I am looking right there. I'm looking at the values that could create zeros in my denominator. And I see the two factors, x plus 1. I'm thinking about what x value makes that 0, -1. And I'm thinking about the other factor, x minus 4. What could make it make a 0? And that would be +4. So I'm going to answer this one in set builder notation. X is an element of the real numbers such that x, I'm going to say, does not equal -1, 4. Okay, this last one is for you to try. We're going to stop this video here. The next one will be a few more examples, and we'll be working with negative greatest common factors.